Okay. So
You know what
gas,
force I'm
gas,
talking
hang
about.
on.
You don't have to ask. You know, you just say it.
What, gravity?
Uh-huh.
Gravity's not a force in your paradigm.
So gravity it can be looked at as a force. There is a force due
No.
to gravity. That's little g. It's the force due to gravity.
Gravity's never been proven with
It has been proven.
where?
Cavendish experiment proves gravity.
Cavendish experiment proved didn't prove gravity.
Yes, it
What
did.
was the independent variable for that?
Sorry, the Cavendish observation proved gravity.
No, what was the independent variable that proved gravity? How did it isolate gravity to
So
prove it was the
they
cause?
isolated it by making sure that there was no other forces that could impart on the. So for the audience, the Cavendish experiment is they had a bunch of lead balls. They had two lead balls that were suspended on a pivot that was suspended by some wire, and then they had two massive lead balls. And the littler lead balls, they would move toward those larger masses. And this is an experiment of proof of gravity. And the
Really?
way that you can do this experiment is you can make sure to use non-electric or non-static materials so they don't have an electric charge. You can do it inside of a Faraday cage. You can do it in a vacuum. You can isolate all of the different variables. So the only thing that can be moving that arm is gravity.
So you can't actually isolate electrostatics completely. Did you know that?
Um,
No,
okay,
you didn't.
what
So a Faraday cage still has
So I like how you
electrostatics.
asked me a
So
question and
hang on
then
real quick,
you answered
you,
for me.
because you didn't know.
I I disagree with you is what it
You just said
is.
a Faraday cage completely removes electrostatics.
I
No, it
didn't
doesn't.
say that.
You
I
said
didn't
it
say no
removes
no 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 no
electrostatics.
no. I didn't say a Faraday cage removes electrostatic
What does it do
charges.
then? What does it do?
It
What does it do?
prevents whatever the hand wavy, oh, it's
You don't know what you're
electrostatics
talking about.
from.
You don't know what you're talking about. Can I
Okay,
speak now?
no, because you
So
asked me a question.
you're the
Do you want me
independent
to tell
the
you lied
independent
about what I said, and then now you're angry that I want to clarify what I said.
the independent variable has to be gravity, the thing that you manipulate in order to prove gravity. Did they manipulate gravity and isolate it in the Cavendish experiment?
They isolated it, yes, and they can manipulate it by using different size balls.
So the independent variable is gravity or weight of the balls. Which one is it?
It is the mass. So it is you can manipulate
So
gravity
not
by
gravity.
using different masses of balls.
What was the dv? What was the dependent variable?
The dependent variable is the direction that the arm moves
So the observed phenomena is seeing things in reality going sideways and getting attached.
towards the massive object. Yes,
Where do we observe that?
in the
Where do we
Cavendish
observe?
experiment.
Where do we observe? That's an experiment to prove the cause and effect. The Cavendish went sideways, right?
Yes, it did. Yes, because we
Okay, where do
also
we observe that
controlled.
in reality?
It's because we also controlled for the downward bias of the globe.
Where do we see that in reality?
Things going sideways.
And sticking to yeah.
So we don't see it caused by gravity very much
There you
because
go.
hang on, let me explain why.
Pointing to a globe.
It is an object I can point to this 3D printed Bernie Sanders, or I can point to this little flowery circle thing. Okay.
Okay, is that more dense than the air, the object you're holding right now?
So is what more dense than the object I'm holding?
That object you're holding, is it more dense than air?
Yes.
Will it go up or down?
That's what I'm asking you. Why does it go down?
Because it's less dense than the medium it's surrounding.
So
So
but
it's
why
more dense
down
than the
though?
medium.
But why down?
Because it's more dense than
But
the
why
medium.
down?
Because we've got an
Because it's more
electrostatic
dense than the
gradient.
medium above it too.
Yeah, so it goes down.
So why is that
Why
why
does
does
the
that
helium
cause?
balloon why doesn't the
So
helium balloon go
wait.
down?
Question.
Why doesn't the helium balloon go down?
Because it is less dense than the air above it.
Okay, that's
But
my
I
point.
have a downward bias.
Really? So do I. Electrostatics.
Okay, so
We have an electrostatic
now
gradient.
we've gotten to my
I
question.
mentioned this at the beginning.
Electrostatics is the downward bias. That's what I wanted. I
And
wanted you to tell me what the downward bias was, because density alone doesn't make sense, because right now there's
I said that
density
from the beginning.
right, but from the beginning I asked what's the downward bias, and you said both density and electrostatics.
Yeah.
Okay, so now we can get to the meat and potatoes of what I'm talking about. So electrostatics is, in your opinion, what makes things go down. The Earth does the Earth.
It determines the downward bias,
Correct. Yes, yes,
density
yes. The
and
downward
buoyancy,
bias. The
density and
gravity
buoyancy.
causes
So
the downward bias, and the density is, we've got the same.
electrostatics
Right, right,
creates
right,
the
right, right.
downward.
Right.
Dude,
I'm
electro.
trying to get a common
I'm
ground.
trying to reply to you. Can you
Yeah,
chill out for a second? Can you chill for a second?
I'm trying to get a common
Electro
ground.
electrostatics
Mhm.
is constantly
All right.
discharging to the
We'll let
earth.
him clarify, and then we'll carry on.
The atmos is positively charged, the ground is negatively charged,
Mhm.
but objects have mass and they're held together with electrostatics that will supersede that force. So a helium balloon is less dense than the medium, it goes up. A rock is more dense than the medium, it goes down. If I drop a rock in water, it's more dense than that medium, it goes down.
Yeah.
If I drop a ping pong ball in air, goes down through the air, sits on top of the water because it's less dense than the water.
Right, right. What I'm excited about is that we have a commonality. Okay. So we have this commonality of what density and buoyancy does. Okay. What we disagree
Archimedes
on,
principle.
what?
Archimedes principle.
Okay, cool.
That's
So
what it is.
we have an agreement of what density and buoyancy does. Okay. Buoyancy brings something up if it's less, or if it's less dense than the air around it, right? So what we are disagreeing on is a downward bias, correct?
The downward bias can be measured.
Right. Yeah. So
Are you denying that there's electrostatic gradient in the atmos?
no, no, I'm trying to get
So
a
what are you saying
clear,
then?
I'm trying to clarify where our disconnect is.
There is no disconnect. You're not understanding. This is you, not me.
That's what a disconnect is. If one of us
You're
isn't
not
understanding the
understanding.
other, that means there's
Yeah.
a disconnect.
Yeah. So what's the problem? What everything
So
I explained to you is correct.
right.
What problem are you
So
having?
you keep asking me what my problem is, then cutting me off when I'm trying to explain. What I'm excited because we've got common ground here. And now we're trying to figure out what that downward bias is.
Electrostatics,
Okay, so how come things still fall in a Faraday cage?
because there's still electrostatics. The object still has mass.
Okay, so it doesn't matter the electrostatics of the atmosphere and the ground.
Like I said for the third time, electrostatics creates the downward bias.
Mhm.
It is superseded by density and buoyancy.
Okay, so what if we were to create a Faraday cage and put a
A
vacuum
Faraday
inside of?
cage still has electrostatics, and the object still has mass and electrostatics.
Right, so but a Faraday cage blocks electrostatics from the outside from getting
Not
in.
fully.
Can you show me?
No, not fully.
Can you show me?
Not fully. Are you claiming that it
Can you show
fully?
me?
Can you show me that it actually does block fully?
I don't know
This is
actually.
your.
I want you your claim.
Oh my gosh, dude. Are you serious?
Yep. So
Okay. So
so
what's your problem now?
so my problem is that there's things, if it were electrostatics, and this is where I'm trying to get to, is you made a balloon float using electrostatics.
You
In theory,
can mimic a balloon, yeah.
you should be able to use that same principle to make anything that you want lighter.
You can
Can you can what is the heaviest
with the Van de Graaff
what is the
generator.
heaviest thing that we have ever
Very
lifted using a Van de Graaff generator?
with a Van de Graaff generator, you can do like iron filings, all kinds of little objects, little,
Okay.
right?
So
But
okay,
if you
so
had
we
if you
can't get
had
past would you agree that there's a certain point that we can't get past, that
yeah,
event
because we yes,
this
because we would
generator just
need
can't lift? Yes.
yes, because you would need to introduce a lot of electrostatics to lift a heavier object.
So what
But
and
you could do it. You
uh,
could do it. Can you do that with
can you
gravity?
show me? Can you show me that
A
happening?
Van de Graaff generator?
No, I want you, because you keep saying we can do it. I want you to
Yeah, a
do
Van de
it.
Graaff generator.
But you said that it can only get to like some iron filings. That's not very much.
That yeah. But the fact that we can do that, can you do that with gravity? Can you isolate gravity and make things float?
Um, no, because
No.
we
Why?
would, because we're still within the gravitational pull of the globe.
Why does the helium balloon go up? Has mass.
because of density and buoyancy. Because remember, so that is why I got excited a second ago. Wait. That's why I got excited for a second back there, is because we agree on what density and buoyancy does. That's why I wanted to specify what your downward bias was. Your downward bias isn't density.
I think we should
and buoyancy.
move on from this because this is going nowhere.
Yes, I would like to go back to the 24-hour sun.
Again.
No, well, you got onto this tangent when I wanted you to
literally just made that point.
But you didn't actually address it. You said dome, and I said prove dome, and then you're like gas pressure.
Oh yeah, prove dome. That's right, gas pressure. Can you give me one example of gas pressure that's not contained, that's not the Earth? Can you give me one example
of gas pressure not contained that is not the Earth?
Correct.
Yes.
What?
Anytime I boil water, there's a denser area over that water, and it is pushing up and is not contained.
There's pressure there?
Yeah.
You're assuming the Earth is not contained.
No. So and you have to understand where I'm coming from. This is why we got into gravity in the first place.
You're putting a measuring pressure in the Earth and saying, look, there's a pressure gradient, therefore it's not contained, when every single example requires containment.
No, I didn't say therefore it's not contained.
Can you create a vacuum without a container?
No, not here on Earth.
Before we do get into
is the vacuum
other. So hold on, just before we continue on, there is a delay on the stream, so it is very hard to try to jump in here. So if it seems like I'm coming on you guys at a really awkward moment, I do apologize. When we go to Q&A, I'll do a re-invite, but just where ADHD was about to say, he's trying to make some clarity. He said, you got to understand where I'm coming from. And then we kind of got into this side tangent. I do want to try to go back to that point and then move on from there. So if you want to clarify their ADHD, and then we'll try to make sure that everybody's coming across there. All right.
Okay. So the explaining where I'm coming from is you're saying that gas pressure can't exist without a container. Well, I'm saying that gas pressure exists where there is a force acting upon the gas, right? Okay, so bear with me. So gravity is pulling, in my paradigm. You can shake your head no and disagree. That's fine. I want you to understand in my paradigm where this is coming from. Okay, so there is a very massive object and it is pulling everything towards it. Okay, and so the reason there is that density is because the further away from the Earth you are, the less the pull is, and so the less dense it's going to be because it's pulling things denser down, and then it arranges. So the answer to this is that gravity exists. Okay, you're saying show me gas pressure without a container. Well, in my paradigm, that container is gravity. That's why we got onto that gravity. I know you're shaking your head because you don't agree with gravity. That's totally fine. I want you to understand where my where it's coming from in the globe paradigm.
Yeah, I know where it comes from.
Yeah. So you understand that to say that where is gas pressure without a container? Well, the globe has a container. You just now have to address that container itself.
The globe has a physical container.
I didn't say physical container. It is the gravity is. It doesn't have to be a physical container. No.
The definition of gas pressure is the amount of force exerted by the particles on the walls of its container.
It's on an area, not the walls of a container. It is on an area.
Area of what? A volume?
Of whatever is sensing it. Do you know what a barometer is?
No. Yeah.
Is a barometer the container of the atmosphere?
No. You're begging the question.
So no, I'm not. So you're saying that.
I'll share my screen.
You're saying that gas pressure is the force against the container. Well, a barometer measures gas pressure. Yes or no?
Yeah, in the Earth.
Yeah, a barometer measures gas pressure.
Is the Earth contained?
Yes.
Is the Earth contained?
Does a barometer?
Yes. Is the Earth contained?
So the barometer isn't the container, but we're still measuring gas pressure. So that means that gas pressure.
Is the Earth contained?
Hang on, dude. That means that the gas pressure is not the force exerted on the container. It's the force exerted on an area, because we can use a barometer to measure gas pressure.
Okay.
If it was only the container, we could only measure it on the walls of the container. So
Okay,
go ahead.
so yeah, so NASA even admits, right? Your Church of Science admits that gas requires a container.
I don't use
Volume
NASA to
of
prove anything.
volume of container. Can you show me a volume where there's
Where
a
is this talking about gas
vacuum
pressure?
right it on screen, bud? Can you read?
But that's not gas pressure. That's not gas pressure.
What does this say here?
That's gas, not gas pressure.
Gas pushes out in all
So
directions.
what this is,
One second. Gas pushes out in all directions on the walls of its container to
yes, but that's
create
not what
pressure.
this is showing.
That Are you kidding me, dude? Is this a container?
Yes, but this isn't
This
talking
has
about
gas in
gas
it.
pressure.
It's literally on the screen, bud. Are you joking? You know
Okay,
how
where
stupid you
show
look
me the
right now?
words gas pressure.
Gas, shape
Pressure.
of container,
Where is gas
volume,
pressure?
phases of matter.
Okay, great. So what
Are
this
you
is
kidding
doing,
me? This is
can I
talking.
respond? Can I
No.
respond?
This
Can
is
I
talking
respond?
about.
Can I
This is
respond?
to,
Can I respond?
this is talking about objects in the container. Container, volume,
All
fixed.
right,
Are
let's
you
let him
kidding me?
respond and
Okay.
give you a little space
So
there. So
this isn't talking about gas pressure.
Oh,
So what this is talking about is the properties of each of the phases of matter. Okay. The properties of, nope, throw that back up. We're still talking about it.
go ahead, talk.
No, throw it back up so I can see it.
Oh, okay. You need to see how it says gas again.
I need to see where it says pressure, but throw it back up because I'm talking
that's
about it.
that's what I was pulling
Throw it
up.
back up so I can talk about it.
Talk. I'm pulling it up.
all right, let's all right, let's just let him pull it up there. Thanks
Okay,
for
great.
doing that, Angel, and let's carry on.
Thank you. I appreciate that because this we're talking about the thing that you're showing and then you made it go away. So a solid, the properties of a solid is that it holds its own shape and it has a fixed volume. The properties of liquid is that it takes the shape of the container, it has a free surface, and it has a fixed volume. The properties of gas is that it takes the shape of the container and it fills the volume of the container. This has nothing to do with gas pressure.
Yes, it does.
No, it does not, because it's not talking about the gas imparting a force against the walls of the container.
That's how you have gas pressure. That's the definition of
Right.
it.
I know that that's what gas pressure is, but
what is the definition of gas pressure? Can you
this
define it?
photo, this picture does not talk about gas pressure.
It's literally on the screen, bud.
Where does it talk about gas pressure?
What? See, okay. Can you define gas pressure real quick?
So gas pressure is the force that the gas exerts on a surface area.
Oh, a container.
It can be the container, but it doesn't have to be
It
the
has
container.
to be a container. No, it
So
has to be a container.
so barometers don't work.
So if you're again
Do
doing a begging
barometers
question,
work?
fellow. Yes, they.
Okay,
Yeah.
so
Is the
then
earth
it doesn't
contained?
have
Is
to
the
be
earth?
the
Is the earth?
container. It can be
You're
something
begging the
within
question.
the container. No, that's not a begging. You can't just
Yes,
throw
it
out
is.
fallacies willy-nilly.
Yes, you are. Show me one example other than that. That's not the earth. You can't do it because you
Okay,
have to invoke the earth.
so again, a barometer isn't the container. That means
Oh my god! It's measuring the gas pressure, right?
right. So that means that
Okay.
how can it measure the
Real
gas
quick.
pressure?
Real quick.
I'm sorry.
Show
Did the middle
I'm
of
going to
my
show.
sentence cut off the beginning of
Yes,
yours?
it actually did because I'm going to show you the
Oh, I'm
definition.
so sorry. Continue. Continue with your interrupts.
So what does this say here? Gas pressure is the force exerted by the
I
particles
don't accept
colliding with
any
the
AI answers. Go find an
walls of
actual.
the
I
container.
don't accept any AI answers.
Okay.
Go and find an actual source.
What? Oh wow, dude. Really? Can you find me a source that says gas pressure is not the wall exerting force on the particles in the walls of the container? Seriously, dude.
Barometers.
Barometer is measuring the gas pressure.
Yeah, exactly. That's my point. You
Is
can't
the
if
earth
it's
contained? No.
by
It's a big in the
gravity.
question fallacy. Big in the question fallacy. So I'd like to move on.
That's not a big in the question fallacy. If it were solely if it required a container, then you couldn't measure it with a barometer. Now, this is what my example of boiling air or boiling water on a stove. Okay, so you have as
You're
the
using the earth.
hang on, we're gonna get there. Just patience. So, if we have our pot of boiling water, what comes out of that boiling water?
Steam.
Steam. Is steam a gas?
Yeah.
Okay, so if I were to put a piece of paper kind of hanging over that pot and that steam came up, would it push on that paper?
Yeah. Would that increase the pressure?
Yes, because that it is
There you go.
exerting pressure on that piece of paper.
Exactly my point. Is the atmosphere
Can I get to my
exerting,
point before you interject?
is the atmosphere exerting
So is that a no
pressure
that I
against the
can't get
walls
to
of
my
the
point
container?
of the example?
Go ahead, dude.
So the point of the example is that that is now gas pressure existing without a container. There
it?
is no container of the steam coming off of my stove. That is pressure
How do
outside
you
of a
okay.
container.
Can
Continue.
you
Go for
how
it.
do you can increase pressure with temperature or volume? That's the only two ways to do it. Can you increase pressure with gravity? Can you experiment with that?
Not without going
No,
outside of the bounds of the
no.
earth. No.
There you go. No. So great.
Okay, but
Can I
that
move on to
doesn't
my next point?
that doesn't wait. That doesn't disprove if gravity were real, you still wouldn't let's assume let's take your stance. Let's take your stance. Gravity doesn't exist. But if it did, then we still couldn't test it because you're within the bounds of the globe. So
then it's not
you're
science.
literally asking something that is impossible if I'm right. If I am right, then you're asking for me to do something impossible.
Can you show me a vacuum without a container?
Not within the Earth's atmosphere, no.
There you go. So you can't.
So
can't
where is
so begging the question false?
No, it's not.
Yes, it is.
You can't just say begging the question fallacy.
You're using the Earth in question as your proof.
No, I'm not. I didn't say that.
Yes, you are.
I said that you just can't do it next to the Earth. You can't do it within the atmosphere.
Okay, great. Can I move on to the next point? This is going nowhere.
Run. Yeah, we can go to the next point.